So let's go through some additional examples of just solving these systems of equations by graphing. Again, our functions are getting a little bit more complicated here, so we're just going to use technology to help us sketch these graphs. I'm going to do a couple examples in Wolfram Alpha. We'll go back and do a couple examples on the graphing calculator so you can see how these different pieces work. All right, so let's start here with Wolfram Alpha. Let's suppose that I want to graph these two functions. Because I want them both to graph at the same time, we can just say graph this and this. And that works really well. However, there's another function that will do a little bit more for us. If we ask it to solve and put the two equations, then it will give us the graph as well as the actual solution intersection, which is really nice. So I'm going to tell the Wolfram Alpha that I want to solve y equals x squared minus 6x plus 5 and y equals negative, I'm going to use 0.5x minus 1. Using the decimal form instead of the fractions just simplifies the notation a little bit so there's no confusion. And using the y's instead of the f of x and g of x, it just seems to take a little bit less processing time. Then we hit enter and we wait and see. These functions, because it's doing quite a bit of things, it's finding the intersections as well as graphing them. It does take usually 30 seconds or so to go, so we can see it thinking hard here. There's my equations that I want it to solve, and it's come up with two solutions for me. The first solution is that x equals negative 3/2 and y equals negative 7/4, and the second solution is that x equals 4 and y equals negative 3. Again, we can see we've got a parabola equation here in a line. This one that's really zoomed out is kind of hard to see, but here you can see the intersections of that parabola in the line. You can use your little cursor thing here. You can see negative 1/2 and just above negative 2, and over here we're at 4 and about negative 3. But the nice thing up here is the calculator was able to find those values a little bit more specifically for us. So what I'd like you to do on your assignments when you come over here is let's go in here, and I think I forgot to put my pen working. And so what I'd like to be able to do is then just go ahead and sketch what my graphs are. Oh, we love pop-ups, don't we? So over here, notice that my parabola comes down at 5 and up at 1, so we kind of have some funky looking thing like this. We have this line that's coming down this way, and I know it's super hard for me to draw this, but then we can identify what the coordinates of those intersection points are. And so 1.5 and negative 1.75. And then my other intersection point was at 4 and negative 3. And so we want to identify what those locations are, have a rough sketch of it so that you can see how these things work. And notice, like here, my parabola should have gone all the way down to negative 4, and that would have been way better. But anyway, I want you to sketch what you see here on the graph, and then over here on the for your homework page, and then also identify the coordinates that you found from the intersection. Let's try another one over here on Wolfram Alpha. If we are here, we're just going to go back up here. We're going to ask it to solve a new set of equations for me. Let's have it solve y equals negative x squared plus 4x plus 1 and y equals 2 to the x power. Let's see how it does with this. So there's my function, so you can make sure it looks like it typed it correctly. Here we can see my plots. I can see that it's crossing twice. Once here at 0, 1 is coming for one solution, and then it seems to be crossing over here somewhere a little bit above 2 and 5. Or, yeah, like 2.4 or something like that. Oh, there we go. 2.3 and 4.9, so almost there at 5. And so the solutions process will go through and give you what those coordinates are, and then your graph is here. If you scroll down just a little bit, you can notice, you can see those shapes a little bit better of those function families. There's my upside down parabola because my x squared was negative. here's my exponential graph of 2 to the x. And when it's zoomed out, you can't see those intersections, but here we can zoom in and see where those actually cross. And there are in fact, two solutions of where those things have that crossing spot. And then you can come over here again, and this is super rough, but identify where those spots here are on the graph by having those windows open, and then give me the coordinate points of my solutions of where those graphs cross as you go in there. Okay, cool. Oh. Get you dizzy here with my pieces. For the next one here, notice that we have 2 quadratic equations. Let's switch over to the graphing calculator just to do something different. Here, if we're using the graphing calculator, we want to go into the y equals screen, and we're going to enter our 2 solutions here, or our 2 functions. So my first function is x squared plus 4x minus 1. And then my second equation is negative x squared minus 4x plus 1. Again, we'll just hit the graph, and hopefully we can see some intersections on the screen without changing the window. And we do. I have a smiley face parabola and a frowny face parabola for my positive x squared and negative x squared terms. I can see it's crossing at 2 places here. One place seems to be pretty close to x equals 0. The other place seems to be pretty close to, let's see, negative 1, negative 2, negative 3, negative 4, somewhere between negative 4 and negative 5. So we can get those locations. We can get very specific spots by using the calculate function. So we hit second trace to bring up the calculate menu, and we'll ask it to identify those intersections for us. First curve and second curve, just hit enter. Move the arrows so that you're close to the intersection point. Here my first intersection happens at 0.236 and 0. Then I'm going to want to do the same thing again. You're going to do second calc. Choose the intersection option. Oh, sorry. Oh, I guess it did that. That's okay. First curve is enter, second curve is enter. At this time I'm going to arrow over, and I want to be closer to that left-hand intersection. And here I get negative 4.23 and 1e to the negative 12. So that's so close, you might as well just put 0 in terms of our intersection. So something like negative 4.2 comma 0 would be great for that. And that gives us our 2 coordinate points, and we can see where those intersections lie. And again, for your graph, come over here and try to get where those things are coming through here and here. Gads. And they're crossing here close to 0 and there. And then we can put our 2 intersection points that we found over here. And I forget what the other one was, but we can plot with that that was like 0.23 and 0 or something like that. So we can kind of come back in here and put what those value points are. All right, let's try the next one. Here's another equation, x cubed plus 2x minus, or 2x squared minus 4. We're just going to go back to the y equals screen, clear out all the equations that are there. We want a fresh start. For y1, we will enter x cubed, x cubed, and we want to go, I think I hit the power button twice there. There we go. X cubed plus 2x squared minus 4 is my first function. 8 over x is my second function. And let's graph it and see how it looks. So over here we have a kind of a funky little cubic thing going here, and then there's my 8 over x, where you have that all that weird stuff happening close to 0, so my graph goes pretty crazy. Notice we have 2 intersection points. We've got one here and one here, and we can use the calculator to specifically find where those values intersect. So we hit second trace to bring up the calc menu. Oh, something went wrong there. Second trace to bring up the calc menu, we want to choose option 5 for intersect. First curve, second curve, just hit enter for each of those. over and make our best guess. So somewhere around here. We get 1.5 or 1.6 for x and 5.0 for y. We'll give a couple more points there. So let's do 1.59 and 5.04. So there's my intersection points there. And then I can find my second intersection point. Again, do second calc, go down to intersect, choose that value, enter for the first curve, enter for the second curve, and then arrow over. There we go, till we get close to where that is. Hit enter, and here I've got an intersection point that landed really nicely on -2, -4. And so this is the kind of thing that I'm after. Show me that you've sketched the graph on your calculator, give a rough idea of what's going on, and label the pertinent points that we're interested in. All right, for the last example, let's go back and try Wolfram Alpha again. This time what we want to graph, I'll slide this over here so we can see both screens at the same time, and close this one down for a sec. This time what we'd like to do is solve these two functions. So we want to solve y equals 2x squared plus 3, and y equals x cubed minus 2x squared plus 6. And let's see how that does. Now notice here we had a cubic equation and a squared equation. With the cubic equation, we do in fact run the risk of having 3 solutions, and that is in fact what happened here. Notice we have 3 sets of results. If you can see them here, you can only see 2 in this version from -1 to 1.5. We see it cross there and there, but this graph is coming back up this way, and it's going to intersect over here on the way back up again. The Wolfram does a great job of locating those 3 intersection points, and your graphing calculator would too. One of them happens right nicely at 1, 5, so there's a nice solution. The other 2 solutions are a little bit messier. One of them happens at x equals -0.79 and 4.25. That's this one here. The other one's going to happen over this way, and it's going to happen way up higher. If you notice here with this intersection, notice that's getting kind of close to 50, so it's up a little bit higher. So here my x-coordinate is 3.79 and my y-coordinate is 31.7. And so that allows us to find each of those different locations. So the graphing technology is fantastic. This would be a huge pain to do by hand and not very accurate. And so this allows us to see the picture and then verify that with what those intersecting coordinates are. So for your homework, again, sketch them on the values on your calculator. On the paper homework that you're turning in, draw a sketch of what you see on your calculator screen, and then specifically identify the points of intersection that solve the system of equations that you were looking at. Hope that helps. Good luck on your assignments, and we'll see you in class next time.